Hi, Remy here and welcome back. In this video, let's see how to connect and configure the eddy current sensor that comes with the SHT36v3 toolhead board. Now let's see the mounting option for the sensor in the CAD software. So the sensor is over here. So this is the sensor and you have the tool board over here. So we need to connect to this particular port. So the flat cable should be connected to this port and over here. You will get two flat cables, one 15 centimeter and second 20 centimeter. You can use either one. I am using the 15 centimeter to connect from this port to this port, which is more than enough. Now let's see Klipper configuration. Before that, we have to make a note that any previous configuration for probe BLTouch must be removed. So if you have any configuration like this, BLTouch, it's auto calibrated over here. Or if you have defined BLTouch configuration like this also on top, make sure that this is disabled and this is removed. You can remove both, but make sure that you remove this configuration. Since I have only one configuration, I'll remove the whole configuration. You need to remove only the configuration that is related to the Z probe. So once that is done, save and restart. So before we start to configure, make sure that your Klipper version is up to date. So go to machine and update manager. So make sure that your Klipper and the remaining configuration are up to date. It is not required, but it is better to have it up to date. Now let's see the configuration. In my case, all the configuration related to eddy current sensor I have defined in this file, which is SHT36v3.cfg. And this file I have included in the printer.cfg file, which is here. Now we'll see the configuration here. So you have two configuration. So the first configuration, this is related to the actual eddy current sensor. And the second one is the temperature probe that comes with the eddy current sensor. So the board itself will have a temperature sensor. So that configuration we need to define here. This configuration is required to do temperature drift calibration. So before we go through this configuration, we need to ensure that in stepper Z configuration, which is here, we need to make sure that the end stop pin, if we have defined a pin, we need to comment it and we have to make sure that we add the virtual end stop. So this configuration change need to be done. So once that is done, we'll come back and let's go through the configuration. So we'll first see this configuration. So over here, this configuration, you can copy from the Mellow website. So this configuration, you copy both the configuration for the eddy probe, eddy current and temperature probe. This both configuration you copy. Once you have done that, we need to adjust this value. So under probe eddy current sensor, we need to change the offset and the I2C MCU. In my case, I'm using this name, which is defined here right on top. So this is the MCU name. The same name you need to define for I2C MCU. So other settings, it is sensor type, the bus and the speed remains the same as per the documentation. Now let's see how to get the offset values. So we'll go to the CAD view. Now this is the bottom side. So the eddy current sensor is here. I can click on the bottom side of the eddy current sensor and on the nozzle on this flat area. So these two sides are selected, and over here at the bottom right, you can see that the offset is set. So I will set this in the Klipper. Now that I can save here, please note that this Z offset is a temporary one just for us to get it started. So we can do the calibration. Once we do that, we need to calculate the actual Z offset and remove this value. So let's save this. Then we'll calculate the X and Y offset. So for that, go to the bottom. Then I can right click on the eddy current sensor and edit in context. You have to click on this, edit in context. Then create a new sketch on the bottom or the top plane. So you can do either by right click and select new sketch, or you can click on this sketch button and then select the plane. In this case, it will be top plane. Once that is done, click on the use button over here or press the U key on the keyboard. And we need to use the center circle of the eddy current sensor, which is this one, and the nozzle hole, which is here. So once we have this, we need to use the dimension tool, which is this one, or you can press the D key on the keyboard. So click on the points that we are using. So this and this point, and then we'll copy this value. Now this value will be for Y offset. So we'll go back to the printer, save this, remove the string, save it. Then we'll come back to the CAD view. Now we need to see what is our X offset. So ideally, there should not be any X offset. Escape key. Then again, we need to click on the use points. So which is this one and this one. Now in this case, we have to move on the top side. So we don't see any value getting changed over here. So this is the right side. When we move, we get the Y-axis. So if there is any value over here, we will get it on the top side. There is another way to check whether this is correct or not. So what we can do is draw a line which is horizontal. Sorry, this should be a vertical line as per the view. I'm not sure. I think this should be horizontal as per the view. And then we can drag like this and then zoom in. There is a slight difference. So we'll copy this, which is 0.00857 mm. So let's copy this and save it here. So this will be our X offset. Now once this is done, we can proceed with the calibration test. But since we are here, let's see this configuration as well, which is for the temperature probe. So the sensor type and the pin, this configuration we have already copied from the Mellow site over here. So the Z move also is mentioned there. So what we have changed over here is I have changed the MCU name, which I have defined on top over here. So this is the name that I have defined here. The GPIO pin remains the same. Horizontal move I have set to 5. Then the calibration position, this is the position where you want to start the calibration. It should be center of the bed. In my case, it is 200 X and Y is 171, which is 200 minus this value, and Z to be at 0.5 mm height. So once the nozzle is at this position, then it will start the calibration. Then calibration extruder temperature. So the extruder temperature should be 170 before it starts the calibration, and so the bed as well, bed to be 110. These values will explore it later when we are actually running the calibration test. Extruder Z height, this is the height. Extruder heating Z. This value is the height of the Z when the extruder temperature or the extruder is heating. That time the Z should be at this position. 50 is the default value as per Klipper documentation. There is one thing to note here. Now you have this horizontal Z move. This should be always greater than the Z offset. Otherwise, it will throw an error saying that the horizontal Z move is less than the Z offset. So make sure that this value is greater than this Z offset. Another thing to note, once you have this set or during the calibration, if you ever want to increase this value, so let's say you increase this to 3.0, then horizontal Z move also must be increased to the difference that you have. So let's say earlier value was 2.5 and now it is 3. So difference is 0.5. Then here you need to add that 0.5, which will become 5.5. So if you don't have that, my original value. Now, if you don't set that or you don't increase that value, then you will get an error which says probe triggered prior to movement. So now we have seen this configuration and we have done the required changes. Next, we'll save and restart. So save and restart. Next, we need to configure Z safe home. So we'll go to the printer.cfg file. My configuration is defined here. So we need to change or adjust this value. I have already adjusted, but let me show that. So for that, I'll go back to the Eddy Current sensor configuration file where the X and Y offset is defined. That is in this file, SHT36v3. Once you go here, I need this value. So we'll copy this, come back to printer.cfg and we'll paste here. This is temporary. We need to remove it and then restart. So how to calculate this is your center. Now my eddy current sensor is slightly left on the nozzle side. So I need to add this value to 200. Then this will be the round figure. Then on the Y side, the eddy current sensor is behind the X or behind the nozzle. 28 mm difference is there. So to bring it in the center, that is center of the bed, I need to minus this Y value from Y center. So this would be normally 200, which is center of the nozzle. So 200 minus 28 will be this value that will be, or that will make the center, bed center for the probe. We'll remove this value, not required here. Speed is to, once you home X and Y and to come to safe Z home position in the center, this is the speed. Z hop, the difference, once the Z homing is done, it will leave this much of gap between the bed and the nozzle. And Z hop is to calibrate the Z height. That time it will use this speed. Once we have this, save and restart. Next, we need to start with the calibration process. So there are 3 calibration steps we need to do. So the first one is to calibrate the drive current resistor. The second one is to calibrate the sensor resonance frequency. And the third is temperature drift calibration. Now we'll start with the calibration process. For that, we'll go to Klipper website. And then in the search bar, we'll search for this command, that is LDC underscore calibrate underscore drive underscore current. And we'll open this link which says Eddy Current Inductive Probe. So we'll click on this and we'll get this page. In this, there are 3 G codes. The first one is this, that is LDC underscore calibrate underscore drive underscore current. The second one is probe underscore Eddy underscore current underscore calibrate. And the third one is this one, that is temperature underscore probe underscore calibrate. So this G code we need to execute in sequence. So the first one is this LDC underscore calibrate underscore drive underscore current. Before we execute this, we have to make sure that our Z height or the gap between the nozzle and the bed is around 20 mm. This command requires the name. If you look here, this name we need to replace with the actual name of the probe. So we'll copy this command in the text editor, then go back to our printer configuration file, which is this one. In my case, it is here. So I'll open this. and this is the name that we need to replace it with. So I'll copy this, then go back to dashboard and then console, and this is the command that we need to execute. Before that, we need to home the printer. Our Z offset we have defined as 2.5. That is based on the measurement that we took from our CAD view, but we'll home it. This will home X and Y, and then Z, it will come at the center and throw an error. Okay, so it has thrown an error, which is fine. Next, before we proceed, we have to make sure that we set Z height to 20 mm. So for that, we need to enable few command or the configuration we need to add. So we'll go back to our machine and printer.cfg, and over here, if you see, I have enabled this force move. So this will allow us to set the Z height or the coordinates for X and Y or Z, the value what we want. So once we have this, save and restart. So once you do that, come back to dashboard and home your axis. Though homing failed, we know that X and Y is in center. Only thing we have to get Z at the height of 20 mm. So for that, we can execute this command, which says X is position 200, Y is at so and so location, and Z will set it to a max height, and then we can enter. Now we have, if you look over here, the all home is set to blue, which means it knows the position that what we have set. Though the Z position is not accurate, it will allow us to set the height that what we require. Please note, you have to be very careful when you are adjusting the Z height, otherwise you might crash the nozzle. So plus meaning increase the gap between the nozzle and the bed, minus is to reduce the gap. So we need to reduce the gap by lowering this number. So we need to do it carefully. So right now the gap is around 60 mm. So we'll bring it little close. Since the gap is around 60 mm, I will use a larger number, that is minus 25, to bring it little close. And I will also simultaneously watch the movement so that it doesn't crash, the nozzle doesn't crash to the bed. So first move, minus 25. Second move, minus 25. So it's around minus 15 now. And this looks to be okay. So right now, by twice minus 25, the Z height is near to the nozzle between the range that is defined, that is minus 20. So I'll execute this command again and say it's minus 20. I think it's, to be on safe side, I'll set a lower value. So minus 15. Now if I try to move the bed less than minus 15, then it will not allow me to do. Next, we can proceed with the calibration command. So we can execute this command now. So with this, when we run this command, it will start to calibrate the very first step. Now we can type the save command. So this will save and restart. So once the restart is done, we'll go to machine and then printer.cfg, and right at the bottom you will find this particular configuration. So it says the probe current, apply the probe name. This is the Eddy current probe, and for that it has registered the register drive current equals to 14. So this value it has registered. We'll close this. Next, we need to run the probe underscore eddy underscore current underscore calibrate G-code. So we need to execute this. So we'll copy this command, copy into text editor, then the my eddy underscore probe name. This name I need to replace with the actual probe name that I have. Go back to printer, then console, and then over here you can paste this command. So when you do this, it will pop up a menu asking for manual probe, where we need to do the paper test to adjust the Z height. Before we execute this command, we need to ensure that the X and Y axis are at the center of the bed. I have created a G-code command, a macro. So let's look at the macro. So this is my macro. Basically, it takes the value from safe Z home. That is what we have defined earlier. So we know that this is the center of the bed where the X and Y position will be. Sets this value. Then it will home X and Y. So this will home X and Y and not Z, because Z is still not known to us. Then once homing is done for X and Y, it will move X and Y to this location as per the defined in safe Z home. So once that is done, next it will set the max value for Z. That means the set kinematic position, it will set as maximum -1. So this way we will get a lot of room to reduce the distance between the Z and the bed. Then it will run the actual command. So this is the actual G code that needs to be executed. So we'll run it from the macro that I created. So we need to run this macro, probe eddy current calibrate auto. So once we run this, it will first home and then bring the X and Y axis to the center of the bed. So we'll start now. Now from this menu, I need to reduce the distance between nozzle and bed. So if I look at the distance, it's around 10 mm. So I will reduce. While I'll click on -1, I also look at the printer, the nozzle and the bed, so that it doesn't crash into it. So the paper is installed. I'll still reduce. Still -1. Okay, this has grabbed a lot. I moved too much, so I'll increase the distance and then do final adjustment. This looks to be okay. So I will click on accept. Make sure to remove the paper. So this will start to do some movement. Now the calibration test is done. So we need to save the configuration. So we'll copy the save. This will, once you execute the save config, it will save and restart the printer. Then we'll go to the printer configuration file, printer.cfc, and at the end, you will see this new configuration added. So we'll close this. So the second calibration test is done. So in this video, I have covered drive current and eddy current probe. And with this, it has already been a long video, so I'll have to stop here. In the next video, I'll cover temperature probe calibration, Z offset, and different bed mesh options. So stay tuned. Until then, thank you for watching this video. Do like, share, and subscribe. God bless and stay safe.